Hello, and welcome to Lesson 10 of Learning Python. Today, we're going to pick up where we left off with the last lesson and talk about the next step in our journey of building a trading bot for OANDA. Let's start today with the next step. And that is the order book. Now, I demonstrated the order book in a brief overview video, and I talked about order book support and resistance. Using the order book in such a way is a very powerful tool, but very few programs actually do it. And that is going to be the focus of today's lesson. Actually reading the order book, looking at the buy and sell spreads, looking at the natural places where order book support and resistance take place. This information is absolutely critical if you want to understand where trades are taking positions and where the weights of those positions are. For example, here we see the amount of volume in this column for the number of purchases. And we can see that the highest purchase is 34, or row number 6. So what this tells you is that the market believes that 0.994 is going to be the best price to handle the largest amount of purchases. And the same holds true for the selling price, where right here 1.001 is the largest level within the order book for sellers. And that gives us a total spread of 70 pips. So before we really get into the code for this, I want to recap a little bit on lessons 8 and 9, because they are very relevant to our next step today. There is a progression between each stage. So let's look at the OANDA 1 program. Okay, we have the very basic necessities of the library. And then we have the actual program that shows the breakdown of how to use the API. Our first generation was very crude. It worked, but it was very crude. It didn't handle errors, and it didn't manage retries at all. But it did do very well at what it was supposed to. Our second lesson took that one step further and moved all of the special functions or the special features like getting credentials and logging in into functions. So now we have a framework where we can actually do this hundreds of times. And it made our main API simpler. So now we have the framework where we can easily look at our main program. 3 simple steps, and we have access to market data. Now you could go through and just use this approach only and not even worry about today's lesson. And it works well up to the point that you need to use 2 sub-accounts at one time. OANDA lets you create more than one account for your token, or what they call sub-accounts. This is absolutely wonderful if you have a hedging strategy, meaning you don't know which way the market is going to go. So you open up a position in both directions simultaneously, such that once you see where the market is going, you close one of your positions and you let the other one run for profits. So hedging strategies are wonderful, but they won't work with this setup because it becomes messy. We don't have a way of providing different sets of credentials for the different account numbers. We don't have a way of containing market data for 2 different accounts and 2 different objects, or I should say 2 different assets. But that is today's lesson, and the most complicated within Python, object-oriented programming. This is what Python really excels at, because everything in Python, including itself, is nothing more than an object. Now, before we go crazy with this, let's start with a very simple definition. An object is nothing more than a big container. Your house or apartment is an object. Each room in your house is an object. And every item from a chair or a table or whatever is an object. So you can begin to see how the bigger object contains smaller objects, and then those objects are grouped within themselves in even smaller objects. This can get messy and complicated very quickly in programming. Just like salt for food, a pinch of it is wonderful. Too much of it and your program becomes unreadable. So learning it is complicated. Learning it is difficult. And really, this is one of the most difficult concepts in Python. Because even though it's obvious to us in our daily lives that we work with objects every day, when you start to compartmentalize your thinking process for programming, it doesn't become as obvious as it should be, because some things become more difficult, as we are now going to see. So here we have the library headers, and now we have a new word, class. Class in Python is how you define a large object. In our class, our object is going to be the entire OANDA API. So we are going to provide an object that lets us manage all of OANDA's communications. And then we are going to tell that object how to do so. So within the process of understanding how we communicate to OANDA, we are creating a standalone part of the language to do it for us. Just like a library, but one we built encompassing and directly to our work here. And there are some very special functions that need to be talked about, and they are confusing at first. The underscore underscore init underscore underscore, or the init function. All objects need them. This is what initializes the object. This is what you store your variables in that the object needs to reference. This is like the key or the doorway to a house. You just can't go through a house any old way you want. You've got to go through the door. That's what the init function does. Self is a very special context in Python. Whenever you see it, that means that whatever you're doing is talking to the object itself internally. So self is always present in every function definition because that's what helps glue the object together. In this case, because I want to provide more than one file name for my credentials, I've declared a regular variable, fname. So fname can be whatever I want on a drive, and it will load the credentials out of it. Now the important thing here, as we look at this, we start to see some of what we recognized from the first previous lessons. The init function automatically does certain things for you. In this case, it is going to get the credentials from the file name we want. It is going to automatically log into the broker for us. So it's going to log into OANDA with our credentials. And then it is going to automatically load the markets. So let's see how that looks piece by piece. So first, we remember the credentials function. We used it in the last program for the markets. All we've done to it is we've given it a way to provide the file name we want it to load. And then we check for the file name if it exists, and then we actually open and read the file name. This function is almost identical to the one we used in the previous lesson, with the exception that as an object, get credentials is linked to the OANDA house. And we'll see how that looks in a few minutes when we actually start using it. And of course, like every other function, it returns the credentials. But if you look, remember up here, the credentials it returns are to a variable within the object. So from this point forward, once we initialize the object, we never need to give the credentials back to any of the functions because the object already knows them. So we don't need to give it the account number. We don't need to give it the bearer token. It knows this on its own from the initialization, which we will see in the next function. Okay, here we are, the login function. And here we see the word self. So login self. This is telling this object, this class, that login is a part of it. And that anything within the class automatically goes to this function when needed. Case in point is our credentials. In OANDA's 1 and 2 lesson programs, we had to provide this information separate from the actual reading part. Here, the object stored it from reading it off of disk, and now it knows it. So we can take advantage of the knowledge we now have. Okay, now let's go to this return line. Now that we've opened up the API connection, we store this information into a variable inside the object called broker. So from now on out, we know this object has a direct connection to the broker. Now the variables can be whatever you want as long as they're meaningful to you. But we know login gives broker. So now the object knows the credentials, the object knows the broker. We don't need to provide that. And we'll see that coming up. Okay, here's the API function we wrote. Now again, reference to self, linking to all of the information that we need to provide into the function from the object. Now we only give it the text name of what we're doing and the request. We no longer need to give it a bearer token, and we no longer need to give it an account ID, because that information is already inside of the object. And as you can see here, the broker information is being used from what we got from the login automatically. Our retry loop, and it prints the results of the retry. And if the retry failed, then it prints the error message and exits. Everything that we got in the last lesson, now just working together in a bigger picture. Okay, let's look at the markets. Again, the self-reference, but instead of having to provide the account ID, markets now only needs to go to its own information. And instead of having to provide the broker information, now it knows the broker information, so all we need to do is provide it with the name we want to display, and then the actual return information or request information from the OANDA library. So our code becomes super simple and easy to read. And then of course we return the results. And now let's get to one of the more meatier functions. The ticker function, self and symbol. No broker information, no account ID. All of that is automatic from the object itself. And this is literally just taken right from the second OANDA lesson 9, and put in here. It's given its self-reference that applies to the object itself, the OANDA object specifically, and then it's using its own internal information that it's learned throughout the process of building this. And finally, the new part, the part we're working on today, the order book. We build out the request, and then we get the request, and then we return to the user the actual order book information, the bids and the asks. So this whole object is just an encompassment of everything we've done in the first 2 lessons, the next step in the evolution of moving forward to a robust trading bot. First, we simply worked on getting the thing to work right in lesson 1, actually beginning to work with the API and getting to understand how they all interconnected together. Lesson 2 of OANDA was to be able to move from just a kludgy system to a more robust system that improved readability. And it gave us a retry loop where if something went wrong, we could go back and try again and make it right. Lesson 3 today, or lesson 10 in the whole series, takes that step and says, okay, now that we know how all this works, now we want to prepare for what's actually going to happen when we build our trading bot. Well, are we going to want to hedge? Are we going to want to compare more than one asset at the same time? How are we going to make all of this work together peacefully and easily? That's what this object does. And now let's actually see this object actually working. Okay, let's stay with this. We have command line arguments. We need to tell the program what pair we are working with. And we need to convert it to uppercase. And we need to replace the slash with an underscore appropriate to how OANDA stores its data structures. That's what we learned with lesson 8, or the first program of the OANDA series. Data from OANDA is not stored the way we're used to seeing it, so we need to move back and forth appropriate to what we're used to seeing. It needs to be in uppercase, so we want to use Python's abilities to convert it. And we want to analyze the depth of the market. We don't want to analyze the whole market, because that will give us numbers that aren't realistic for our day-to-day trading. We want to analyze only some of the market. So that's our depth. And of course, we need to have both of those arguments, or we tell the user that we need to have both of those arguments, or parameters. Now, you remember lessons 8 and 9. It took us 3 steps. 3 steps. We had to read the credentials, we had to log in, then we had to get the market. Now, all 3 of those steps are done right here. And we access the market through the OANDA special variable. Let's actually go back and look at that. Here we are. Self markets is the special object variable that the OANDA class actually loads the markets in for us. So all 3 of those functions were done automatically with one single command. And specifically, we give it the credentials file name. And this can be anything you want, or even 2 different things if you want to work with 2 different sub-accounts on OANDA. You could have broker 1, broker 2, and literally have the access and conveniences of 2 different accounts in a easy to read format. And as you can see here, we're going to get the ticker information. All of that information we did, one line, broker, get ticker, no more account numbers, no more bearer tokens, none of the weird stuff. We just say get ticker and then the pair or asset we want. And because we did all of the work in ticker already in the functions from lessons 9 and 8, well, actually lesson 9 only, all we have to do is just get the price. It's already a floating point number. We don't have to worry about converting it. It did it for us. The object has that same encompassment, and it's readable. And finally, we get to reading the order book itself. And again, no account ID, no bearer token, none of the weird stuff. And you'll notice in each case of using the process, we don't specify the self at all. Self is strictly for the object internally to know how it works. So we have encompassed really within a matter of 6 lines, well 5 lines from lesson 9, what it took a lot of code to do. So we made our program readable, easy to follow, and we've made it efficient. And on top of that, we've done so with an extension to the language that lets us communicate with OANDA efficiently. Now we can begin to actually analyze the address book. And that is what all of this stuff starts to do. First, we set up all of the variables we need. Long positions, short positions, the length of the order book. Now, index. This is where we track the maximum of the buy index and a sell index on the basis of our depth. And we'll go back and we'll demonstrate that a little more. The new table or list we're going to create, the previous position, the current index, and then our loop. Let's look at our loop. So we are going to take each entry in the order book one by one. We're going to figure out what the weight of that is, and you can use the show stop function to see exactly how this is. This is a percentage by default according to the OANDA API. So here we are making it a percentage and multiplying it by the length of the list to give us a value we can then begin comparing. And of course, above all, we have to convert it to a floating point number. The actual price, we've seen this before, but we're pulling it out of the order book and we're rounding it to 4 positions, or pips. And now we have the selling price, or the percentage of weight within the order book that this price actually has. So now the current price is the price we got above. So now we're checking to make sure that we have the previous price has to be less than the current buy price, and the current buy price must be less than or equal to the current price. Now this is a bit of a tongue twister, but when you look at your bid and asks, what this is really saying is that the previous price is going to be our least balance. The buy price is going to be our current price in the order book. That level that we are at right now if we were to purchase it. And then the current price in the order book, that is right now the number that we're looking at right off of the order book itself. The current record in the order book. And if the condition is met and this range is specific, for example, if you're on the first entry, you're not going to have the position match. But if you are not in the current position, meaning if you're in the line of what this needs to be, so you got your low, your current, and your higher prices. If you're in that line, then we know we've hit the right spot of the order book. And this is a little confusing to understand because the order book contains every order imaginable, from the highest point that someone thinks this asset is going to go all the way down to zero. We only want the price that is within range of what the market currently has right now. And that's the hard part. So let's see, do I have show stop here? Alright, so let's actually take and right here, so the buying price, now we're going to put buy price, the price you pay if you were the purchasers right now. We're going to put sell price, and we're going to put the current price or the current position of the order book. Which means we need to move this up to here. So let's actually see what this does. So let's run it. And I'm going to use a Linux screen program, or paging program, I guess is a better word for it. And here we go. We have the order book pricing. So somebody actually has this asset, Euro USD. They put an order in on the book for $29. But our actual buy price is 99 cents. So what we have to do is sort through all of this and find the order book place. And as you can see, if we go down, there are a large number of orders at zero, where somebody is actually betting that the US dollar against the European dollar is going to go to zero. And as you can see, there are a lot of people who are betting on it going to zero. And there's people who are betting on it going to $2, $4, all sorts of prices. So as we collect the order book and we begin to look at it, you see just how graphic and dramatic this range is. And that's the problem as to why we actually need to filter based upon the actual prices we want right now from the bid and the ask. We need to make sure that the information we are collecting is accurate. And of course, we need to take and collect the total volume, because in order for our percentages to make sense, we must know how much volume is in the order book. And then we add to our new list the buying price, the current price, and the selling price of the order book. Or I should say buying volume. How much volume is being bought at this price and how much volume is being sold at this price. Now the previous price equals the current price, and then we bump the index so that we can continue counting and comparing and collecting information from the order book into the amount of trades we want to list on the screen. And then of course, this is just nothing more than actually displaying that information. Here is our nice fancy table column header that gets printed on the screen. You see I'm using a few more tricks in Python to format it correctly. Play with this. Test it out. Find out how these little tricks work, because they will help you make your information more readable. And now we display the table. I don't want everything in the table displayed. I only want so many entries around the beginning, and I should say above and below the bid-ask prices. And I only want the maximum within my depth range analysis. So first we set our variables up, our borders, and our prices. Max buy orders, max sell orders, max buy price, max sell price. And now we actually look at our depth. If our depth is 20, we only want 20 values away from the bid-ask spread. And that's what we're doing here. The index we saved above, well, that's the index that our price is at, the price we want to compare. And it is the first entry of the list that we created. The buying price is the second entry of the list that we created. Remember that lists are zero-based, like everything else in programming. The third entry is the selling index. The fourth entry is the selling volume. So we're using the volume, price, are two fields of an index, but we have two different pointers that we're using. The buying index here, and this, up here, and the selling index down here. Two different ways of looking into the same table. And now we're going to collect our spread. And now we're going to check, is our buy volume greater than the maximum buy volume we've seen so far? If it is, then we want the buy volume and the buy price updated for our variables, so that when we get to the bottom of the table, we can print that information. We do the same thing with the sell volume and sell price. And then we print out every single line appropriate to the depth of the order book we are examining. And this is just a nice little counter for the row number that we see on the left-hand side. And finally, we calculate the spread of the maximum buy price and the maximum selling price, and then we finish off the table. So let's see how that looks again. And I need to take that out. Let's save this again and try it again. So, this is the C variable, the counter, that simply counts the row number of what we've examined. 15 depth from our buying price and our selling price, and the buy index and the sell index appropriate. Now, the way I figured this out, in the order book, when you look at your prices, you want the buying price to be less than what the market is willing to give you if you bought it right this minute. So you want to see 15 positions previous to the current price you pay right now. The same is true for the sell order, but you want it to be 15 positions ahead of what you would sell it for right now, or more expensive. And as you see the maximum down here, the maximum level is roughly 34 orders at 99.4 cents. And then we have roughly 16 orders selling it at 1.001. And if we was to set up our buy and our sell right now with this information, this is a 70 pip spread. Now what this tells us is our reward. So if we know right here, this is our reward price. Get my mouse to work. Here's our reward. Now if we want a risk to reward ratio of 2 to 1, then we simply take 70, divide it in half, and subtract it from this number, and we have our stop loss. So just by looking at the order book, we see where all of the orders are. We see where the buyers want to put all of the money. We see our reward ratio and where the buyers think the selling point is going to be. From there, we can calculate our risk and set our stop loss. Everything we need right here for an order confirmation. And it's done in a nice, neat, convenient way. But you don't have to stop here. You might want to see what the maximum is going to be on a bigger scale, like 200 depth. And you actually see the buy order is still focusing around 99.40. That's critical because this tells you where the market is putting all of the money for a natural support line. But by increasing our depth, we now see that the market really thinks that by a heavy amount, the selling price or the natural resistance level of the order book itself is going to be 1.006. So you have here literally some of the most critical information you could possibly have out of the order book. And you can use this information directly to enter into a trade algorithmically, letting the computer set it up. You've got the risk, you've got the reward, you've got the entry, you've got the exit, you've got all the components you need. Or you can use this as a part of the process for your automated trading, meaning MACD, Bollinger's, RSI, parabolic stop and reverse, whatever technical analysis you wanted to use. You could apply that, and if it matches with this number, take an entry point. Or if you get that the buy signal is now, place a limit order and let the market sit and take it. So you have a huge amount of options here that you can really explore with just a little bit of work. But it makes it easier now because of the class system. And now we're going to talk about where it really shines. Order book information is not something that you'll find historical data to. So if you're looking at an arbitrage or comparing the same asset on two different brokers, the class framework, the class system becomes a way where you can now have a class for OANDA and a class for, say, Forex.com or Gains Capital. You can now open both exchanges at once through the process of the order, load both of their markets, and compare assets side by side that both exchanges share, and have a clear and consistent framework to do it with. This is where the class system in Python really begins to help control and manipulate the data that you have, because this program has a lot of data to it. The order book is a nightmare, and it takes a lot of time to download, compare, and analyze. Just the analysis part here for trying to figure out where the bid and the ask price are within the order book and calculating the appropriate volume weights is a challenge. But having the ability to do it on multiple exchanges simultaneously is a power that is really immense. So classes are a way of taking a lot of different similar functions or similar brokers or similar exchanges and being able to collect data from them all at once and compare them in a meaningful way. It is one of the most difficult aspects of any programming language, which is why I waited until the last real component to talk about it compared to all of the other features we've talked about. So from here, where do we go? We have the order book. We have basically the blueprint of the exchange. The only thing we're really missing is how do we actually buy and sell on the exchange. That is our next step. And from there, we can begin to build our bot. we can begin to think about what we actually want to use to begin to really try to trade with. What strategy? What mechanism? How do we want to enter the market? How do we want to get out of the market? All of that now becomes a realization. But it also means things aren't going to get any easier. Even though we've covered all of the rough spots of the language, it's still learning how to apply all of this knowledge and information towards our goal. And that's really the hard part of courses like this. Crash courses, goal-based learning, boot camps, whatever word you want to give them. They're hard, they're difficult, they're tedious, and it's a lot of information in a very short period of time. It's not easy learning this kind of information such aggressively, or so aggressively. It requires perseverance, tenacity, and a certain level of stubbornness. So as you continue forth, keep in mind what your goal is. Your goal is to write a trading bot that will hopefully make you money. Don't expect and don't try to learn everything. Learn what you need to accomplish the goal. If you have a question, be sure to ask it in the comments or on my support server, so forth. It is important that you ask. Practice. This program has a lot of things that you can take apart, analyze, and study. Going through the order book is a huge wealth of information. I've only touched on one way of using it. There are literally countless ways of using this information to provide a wide depth and breadth to your trading and to your abilities to trade. And of course, this program will be put on the GitHub repository. Download it, play with it, test it, see how the market works. Because the one thing that is really nice about this is you can actually take with a Linux VPS. And let's make this realistic. Linux has a special command. Where you can actually sit and watch your order book and see how it works. And in the upper right hand corner where you see the time, you'll get an idea of how long it takes the program to actually read the information. And you can adjust the delay appropriate to that amount of time. This really is an incredible work of technology. A lot goes on here that helps traders just like you and me maximize our abilities. It's untapped information for most of the market, and it really shouldn't be. This is an incredible resource that can't and shouldn't be ignored. Just sitting here looking at the numbers, not the pictures like what OANDA gives you. Looking at the numbers here, you begin to see a lot more. You begin to formulate the concept of price volume within the order book, or what many large investing firms call smart money, by looking at the volume of the order and where that price is, you can begin to see where you need to enter and exit the market to help protect your investments. This is really just the tip of the iceberg. And there's so much here that I could really go on with a large number of different approaches you can use and probably bore you to tears in the process. But take this program, run it, test it, use it. It's not just Euro USD. Any Forex pair. For example, let's do, I only want to do 15 for the screen. Let's do JPY USD. And it didn't find it. But notice our retry method. It retried, it didn't find it, it aborted. So here we are, USD JPY. And you see the pricing, you see the volume, and you see the spread. Look at that spread, 170 pips. This coin is expensive to trade. But you see exactly where the market is. So using this program in combination with the list markets, you can really begin to see how we're honing in on how and what our trading bot is going to need to think and solve the problem of what coin to trade and where to trade it at. So make sure you leave me a comment if you have any questions. Ask away. I'll be glad to answer them. Until next time.